Hello, everyone. 1 second here. Let me log on to my iPad. So we're going to go over the review sheet, and then I'll answer any additional questions you may have. So keep in mind, besides the review sheet that we go over, things you want to study, focus on. Remember section 4.3 was it that I put additional questions on Canvas for you, and then I put the answers up there. Make sure you know how to do those type of questions. Also for 4.7, the word problems, make sure you're familiar with doing word problems as well. So I can do an additional question on word problem after I go over the review sheet. And then yeah, and then of course questions on the review sheet. So any particular questions, anything you want to discuss before I start going with the review sheet? Oh, yeah, and also this review sheet, I posted it on Canvas for you. So I'll go over it as if like I haven't posted anything, but if you ever like can't keep up and you want to just pay attention, feel free to. And this is all written out for you already on Canvas. Hopefully I didn't make a careless mistake. So let's go over the review sheet. So again, the best way for you to prepare for the test is if you've already tried to do this yourself, as opposed to just wait for me to go over it. Number one. Now, for number one, it's kind of a question that just tests your understanding. We didn't have a homework question like it, but it's a pretty easy question. So it just says, determine if the graph of y equals x to the third minus 5x plus 6 is concave up or down at x equals 2. Well, what determines concavity? It's the second derivative. So we're going to take the derivative and then take the derivative again. Here's the first derivative. The second derivative is just 6x. So what's the second derivative at x equals 2? Well, 6 times 2, which is 12. It's positive, so therefore it's concave up. So the answer is concave up. And that's all I'm looking for.
Professor, can you just explain it one more time? Is it because it's positive, right? That's why it comes.
Yes.
Okay, thank you.
So Madison, yeah, you can't leave that because you need quorum.
Okay, we need quorum for math class. That makes sense.
Number two. Find all relative extrema. F of x equals negative 8 over x squared plus 1. So first we got to get the critical numbers. So the derivative is, we're going to use the quotient rule. Bottom times the derivative of the top minus the top times the derivative of the bottom, all over bottom squared. So anything times 0, that's just 0, so that goes away. So we got negative over negative, so that's positive. 8 times goes to 16x over x squared plus 1 squared. Now, this derivative is a fraction, so the derivative equals 0 when the numerator is 16x equals 0. The derivative does not exist when the denominator x squared plus 1 squared equals 0. So you got to watch out for two things when you have a derivative that's a fraction. In this case, 16x equals 0, that's just x equals 0. On the right side, well, if I square root both sides, x squared plus 1 equals 0, x squared equals negative 1, x equals plus or minus I. There is no real zeros here. So you don't even have to do this, because if you just look at this, actually not that, but look at the denominator here, without even doing the algebra, notice when you square something here, the smallest that it possibly be is 0. But then you're adding 1, so now the smallest possibility is 1. Squaring it, you're still at 1. So the minimum the denominator could possibly be is 1, no matter what x is. So it could never be 0. So really, you just have to worry about the numerator, 16x, and that's 0 when x equals 0. So your only critical value is 0. So what's the y value when x equals 0? Well, you plug it back in the original. So if I plug in 0 for x here, 0 squared plus 1 is 1, so negative 8 over 1 is negative 8. Now I got to determine if this point is a max, min, or maybe neither. Now, for this particular problem, I'm going to prefer to use the first derivative test. Normally, my go-to was the second derivative test. But I don't want to take a derivative again and make it even more of a mess. So, first derivative test would actually be less work here. So I'm going to pick a value to the left of 0, and pick a value to the right of 0. Again, the negative 8 is just there. So the first derivative is 16x over x squared plus 1 squared. When we pick a value left of 0, let's pick negative 1. So 16 times negative 1 over negative 1 squared plus 1 squared. So that's negative 16 over 1 plus 1 is 2 squared, 4. So negative 4. So the derivative is negative, so therefore it's decreasing. Now let's pick the value right of 0. Let's pick 1. So you got 16 over 1 plus 1 is 2 squared is 4. So 16 over 4 is positive 4. So again, it doesn't matter if you got 4 you use positive, so it's increasing. So at our critical x value here is 0. If it's decreasing on the left-hand side, and it's increasing on the right-hand side, so therefore it's a relative min. Any questions? All right. Let's move along to question number 3. And again, for those of you who came in a little late, this is all already on Canvas for you. Over what intervals is f of x increasing, and over what intervals is it decreasing? So again, we got to find the critical numbers. Oh, by the way, so Aaliyah told me that she won't be able to make it in today's class, but she's still having tutoring. Is it after class today? Yeah, so she'll still be there, but she's not here right now. Okay. 6x squared minus 24x. Set the derivative equal to 0. Factor out of 6x. So we get x equals 0 or x equals 4. So there's our critical numbers, 0 and 4. So we got three regions to test to determine where it's increasing or decreasing. And you're going to pick a representative value from each region and plug it into the first derivative. Why? Because the first derivative tells you if it's increasing or decreasing. So pick a value from to the left of 0, I'll pick -1. In the middle region, I'll probably pick 1. That's the easiest. And then the right side, I'll pick 5. So you guys go ahead and finish this if you haven't done so already, and I'll catch up in a minute. You know what's really weird? I'm looking at the weather app on my phone, and it says in Fullerton at 4 p.m. there's a 90% chance of rain. But then it's sunny now, and it's going to be sunny at 5 o'clock. For that 1 hour period, expect rain in Fullerton, 90% of it. So imagine you just going out for a nice walk, and then boom, you get showered with rain. Can you guys check your app? Do you see the same thing for Fullerton? No, I have a better app than the Apple app. I have this app that I downloaded, Weather Underground.
It says 40% now.
Okay, I probably got to refresh it now. Oh, yeah, just a little spike now here. Wait, today is the Tuesday. Hmm. 46%. There. Yeah, because I'm looking at the clouds. It looks pretty normal to me. All right. Okay, so let's plug in -1. 6 times -1 squared minus 24 times -1. So 6 plus 24, that's a positive. That's all we care about. So it's increasing. Now let's pick a value between 0 and 4. I picked 1. 1 squared. 6 times 1 squared minus 24 times 1. So 6 minus 24 is -18. So it's negative. Now, again, if you pick, let's say 2 or 3 or any other value between 0 and 4, you would still get a negative result, which means decreasing. Now plugging in a 5. 6 times 25 is 150 minus 120 is 30. All right, so here's how you write the answer. Increasing on -infinity to 0, union 4 to infinity. Decreasing on 0 to 4. Does that make sense? Desiree. Oh, you're here, Desiree, the physics major. Rachel, no more video. James, where's the video? James Kang. Sorry, bad hair. Really? Rachel, what's your excuse? There we go. Yeah, you can do a virtual background. There we go. Oh my God, James, it's the same background. All right. I'm already on my second Coke Zero today.
That's a lot of Coke.
It's only second. Madison, what is your drink of choice?
We've been getting these one like smoothie things from the store, and I don't know what they're called, but they're kind of amazing. And so currently, I've been drinking a lot of those.
Is it like an icy?
Yeah, it is. I wish I knew the brand name, but I can't think of it.
Lauren, I said Coke Zero. How can you think of another type of Coke?
I didn't say anything. I just laughed.
Oh, James, sorry, that's the different type of Coke. James, sorry, I saw the LOL. Never mind. No. I do not make even jokes about Coke because once you get too addicted to that, what number was I doing next? Oh yeah, number 4. 2% milk is the best. Oh, H Ram, where are you at? Oh, there you are. I don't like when people like when I drink hot tea, they said, "Would you like some cream or milk?" No, it's tea. You don't put milk in tea. It's actually probably an English thing, but Persians, we just drink hot tea. No, just water-based. We have, sugar and cookies and stuff with it, but no milk. All right, 3x squared plus y squared, where x plus y equals 5. Okay, so this is from the optimization section, but this is like the easier question because you don't have a word problem. So you take your secondary equation, you can solve for x or y, but I'm going to solve for y, 5 minus x, and then you plug it into your primary equation that you're trying to minimize. So you got q equals 3x squared plus y squared. But what is y? 5 minus x. Now, before I take the derivative, I'm going to actually multiply this out to make it easier. 5 minus x whole quantity squared will be 25 minus 10x plus x squared. Combine like terms, q equals 4x squared minus 10x plus 25. Now take the derivative, 8x minus 10. Set it equal to 0. 8x equals 10, divide by 8, 10 over 8, which reduces to 5/4. Now, if x equals 5/4, now we're going to get y, which is 5 minus 5/4, which would be 20 over 4 minus 5 over 4, which is 15 over 4. So x equals 5/4, y equals 15 over 4. Now, how do I know this gives me a minimum? Well, you can do the second derivative test. Q double prime is equal to 8, which is concave up, which means you have a minimum at the critical value, and that's what we wanted, minimum. So this is the answer. Any questions? Hey, June, what happened? I expected better from you, Hey, June. I understand someone like James is a slacker. Hold on. Miguel. Well, yeah, slack on the video being on. Miguel. Miguel, what's your last name? I don't even know. Who's Miguel? Oh, Miguel Lopez. Okay.
My last name's
Her day-
Lopez.
Huh? Okay, I just said that. Yeah. Her day, I can't even. I see your ceiling now. Come on, what the heck is this? You bunch of no good videos on, please. Moving on. Number 5.
Professor, I have a question.
Well, I can't see you. Maybe we'll turn the camera down a little bit. Oh, there you go. Okay. It's the lighting in the room. Okay, go ahead.
So when they say minimize and maximize, we just do the same thing, right?
Yes. The procedure is the same. But what happens when they ask for a minimum and you do the second derivative test, you should get a concave up, so it's a minimum. But if when it's a maximum, it should be concave down, so it's a maximum.
Got it. All right. Thanks, Professor.
Her day is like, you're too polite. I'm not used to having students like you. I'm more used to students like, there's no rude students here, actually. Oh, you should join my college algebra class tonight. We have a couple winners there. Not meaning in that. Never mind. I'm not going to say anything there. Okay. So number 5. From a piece of cardboard, 20 inches by 20 inches, square corners are cut out so that the sides can be folded up to make a box. What dimensions will yield a box maximum volume? What is the maximum volume? Did you have a homework question like this? Or I think it may have been an even number problem, so you didn't do it. Anyway, we're going to do it now. So you have a thin piece of cardboard. Well, they didn't say thin, just a piece of cardboard. 20 inches by 20 inches. And you're going to cut out square corners. And then when you cut out these square corners, what's left here, again, this is supposed to be a square. I know it doesn't quite look like it. When you cut out the square corners, you're going to have these, you're going to have a square base here. And so the question is, so when you have it, you're going to have these flaps here. See the orange part that I'm highlighting? These. So when you cut out those corners, these are the orange part is going to be what's left on the side. And so look at the video that I'm in right now. So when you have this cardboard box and you cut out the corners, the orange parts that are left, those flaps, you're gonna fold them up. And you're gonna make a box with an open top. Can you visualize that? Okay, so the question is here, how big of a corner should you cut out? Because if I cut out too small of a corner here, then I have very little height on the box. If I cut out too big of a corner, then I have very little base left here. So there's the amount that's just right. I don't know how many inches that is, so we'll call it X. But if I cut out X inches there, then I got to cut out X inches here because you can't have one wall be different than the other. And this is going to be X, this is going to be X, going X all the way around. And every corner. So what would be the distance from here to here? Well, it would be 20 minus 2x because, well, the whole thing is 20 from here to here. So if I cut out X inches from here and X inches here, this would be 20 minus 2x. Similarly, this would also be 20 minus 2x. The distance from here to here. All right. And then once you once you fold it up and you get your box is going to look like this. So, oops. So it'll be, this is your 20 minus 2x. This is the 20 minus 2x. And this is your height, x. So this is the base of the box. And this is the base of the box. The other part you can't see. And then the flap would be where you fold it up, which would be right here and right here. And it's an open top. So remember, volume of the box is width times length times height, right? Width times length times height. So we're trying to maximize volume. So what is V equal to? The width is 20 minus 2x times the length, which is also 20 minus 2x, times the height, which is just x. So I want to know what dimensions will maximize the volume of the box. Meaning, if I can figure out what x is, that will tell me how many inches I should cut out from each corner. So let's multiply this out because I know I got to take the derivative soon, and I'd much rather take the derivative when it's all multiplied out. So first, I'm going to go 20 minus 2x times itself. So I get 400 minus 40x, another 40x, so minus 80x plus 4x squared times x. Distribute the x, 400x minus 80x squared plus 4x cubed. So now we're going to take the derivative. And I'm going to set the derivative equal to 0, and I'm going to rewrite it in standard form as well. All right, I'm going to divide everything by 4 here. So 3x squared minus 40x plus 100 equals 0. Factor two numbers that multiply to 100 minus 10 and minus 10. And you notice the inner product here is negative 10x, outer product is negative 30x, which adds up to negative 40x. So we get x equals 10/3 or x equals 10. I'll wait until you guys catch up here. I want to see how I wrote this out. 1 second here. I want to see. Hold on. All right. Now remember what x represents. X represents how many inches you cut out from the corner. Does it make sense to have x equal 10? If I cut out 10 inches from this side and 10 inches from that side, there is nothing left, no base left. So it can't be 10. You don't even get a box. Now, the other way you can tell that it's not 10 is because if you do the second derivative test, if you take the derivative of the derivative and you plug in x equals 10, you will not get concave down. You'll get concave up, which means it's not a maximum. So x equal 10 is not going to work. So how about 10/3? Well, that's 3 1/3. That looks more reasonable to get cut 3 1/3 inch from this side, 3 1/3 inch from this side, and you'll have plenty left for the base. You can also do the second derivative test to see that it's going to be concave down, and it'll give you a max. So the x should be 10/3. Now, what is the width and the length? Well, that's 20 minus 2x. So if you were to take 20 minus 2x, that would be 20 minus 2 times 10/3, which would be 20 minus 20 over 3. So you got 60 over 3 minus 20 over 3, which would be 40 over 3. So that's the width and the length, 20 minus 2x. So the dimensions should be 40 over 3 by 40 over 3 by the height, 10 over 3. These are the dimensions of the box, width, length, and height. That will maximize the volume. What is the maximum volume? Well, whatever the product of those three numbers are, which would be 16,000 over 27 cubic inches. By the way, how many of you got this before I did it? Does it make sense now, at least? Okay. Now remember, we did different problems from the word problem section. So I'll come back to this in a second, but if you remember the optimization section, section 4.5, here, number 15 here, we did maximizing volume where you have certain requirements. 23, minimizing distance. 35 is the one where you have a poster printing size. You're trying to minimize the poster size given a certain something. Now, don't worry about number 37. That's a tougher one. I'm not going to test you something like number 37. But we did other problems in the notes. Remember where you had a certain amount of fence and you're trying to maximize the area with a limited amount of fence? Then you had minimizing a vertical distance, or you had minimizing distance area, like you have a graph, the point. So you had, like number 23 here. So go back and look at the notes from that section and the different type of problems that we did. So be familiar, because you will have at least one word problem from something. But that's not the only thing you want to study. You don't want to study like that and then miss 3 other questions because you were just studying one type of problem the whole time. So study the easier questions as well from other sections because you still want to know those as well. All right, how are we doing? Good? All right, so next, number 6, 7, and 8. So let's rewrite this as x to the minus 4 plus e to the 2x. So we're taking the antiderivative. So going back from f prime, you just come f of x. So add 1 to the exponent, -3. Divide by -3, -1/3. plus antiderivative of e to the 2x is itself, divide by 2 plus c, and that's it. Or you could write it like this if you want. Now, if you write it like this, make sure you're familiar. So if you write it like this with a negative to the -3, then x needs to be in the middle or on top. Here, it's on the bottom because you drop it down, so it's a negative x, and then plus c. So either or is fine. Number 7, f prime of x is equal to 2 sine of x plus 1. What is the antiderivative of sine of x? Oh, I missed the questions here. Yes. Robert and, oh, how did you get the second? Oh, yeah. Omar, yeah, that's the question. Yeah, thank you guys for answering. Yeah, because the length and the width are both 20 minus 2x, so they're both 40/3. So the antiderivative of sine is negative cosine, and here's why. Because the derivative of cosine is negative sine, but you want it to be positive sine, so you got to put a negative sign there. Oh, I forgot the 2. Negative 2 cosine. And then plus the antiderivative of 1 is x plus c. Number 8. F prime of x equals the cube root of x squared plus secant x times tangent x. Let's take the antiderivative here. Well, let's rewrite it first. The first one, add 1 to the exponent. 2/3 plus 1 is 5/3. Divide by 5/3 is the same as multiplying by 3/5. Plus, now the secant x times tangent x, there's no such thing as product rule or quotient rule, and you can't treat them like separate questions. But if you remember, these are problems that you should know how to do. You remember the derivative of what gave us secant x tangent x?
Secant x.
Yes.
Secant x.
Yeah, correct. Plus c. So there we go. So there's 6, 7, and 8. Cole, how are we doing over there? Desiree, are you still sticking with physics? Cole, what's your major, by the way? Computer science?
That's one of my final choices. I'm still trying to
Oh, well, what's in the
Get
running?
down
What are
to
the
it.
like the top 3 you would say?
computer science, mathematics, or film.
Or film? That's kind of like different than the other 2.
Yeah, but it's something that I enjoy doing.
Mm-hmm. So I will tell you this, Cole. If you decide to major in film, minor in math. That way, if you ever come back to school years later, you got a lot of options because a lot of stuff requires you to know some math and you already got it. All right, so number 9, you have f double prime of x equals sine of x. F prime of 0 equals 1. Equals 0 equals 6. So we want to know find f. So we got to take 2 steps back because right now we're at the second derivative. So if you go 1 step back, you get to the first derivative. 1 more step back, you get the original function. So we do this in blue. So f prime of x, we're going 1 step back. What's the antiderivative of sine? Negative cosine of x, right? Plus c. Because the derivative of cosine is negative sine, so therefore the derivative of negative cosine will be positive sine. Now, before I continue, I got to use the fact where f prime of 0 equals 1. So plug in 0. You get 1. Cosine of 0 is 1, so negative 1 plus c equals 1. So add 1 to both sides, c equals 2. So f prime of x is equal to negative cosine of x plus 2. Now we're going to go 1 more step back to go to the original function. I'll do that in red. So f of x is going to be, what's the antiderivative of negative cosine? Negative sine. Because the derivative of sine is cosine, so the derivative of negative sine is negative cosine. Plus 2x plus a constant, which I'll call d, because c is already equal to 2 in this problem. So now we're going to use this fact. F of 0 equals 6. So if I plug in 0 for x, I should get an output of 6. So this is all 0, so d equals 6. So my final answer is f of x equals negative sine of x plus 2x plus 6. How about that? Hey, you know, I would have been living a little bit underneath a rock. But I remember a few years ago, there was this one teenage girl that was on Oprah, the one that she was fighting her mom. Apparently she's a rapper now and a millionaire. The one that cussed a lot, what was her name? She stole money from her mom and everything, and apparently she's popular now. You guys know what I'm talking about? Like Catch Me Outside or something?
Yeah, her name is Bad Baby now.
Oh, okay. People like her?
Apparently.
She stole money from her mom. Like, how much worse of a person can you be? I mean, if she steals money from her mom, God knows what she'll do to the poor bastard that eventually dates her. All right, moving on. Number 10. All right, so what are we doing on this problem? Express the limit as a definite integral. So we got the limit of a Riemann sum here as n goes to infinity of the summation from I equals 1 to n of x sub I squared plus 3 times delta x. So that is equal to the integral from 5 to 8 of x squared plus 3 dx. Did you guys get that? All right, now we're going reverse on number 11. So this one is, so the interval is from 1 to 4, but you got to do a little bit more work going this way on number 11 because you want to figure out what your delta x is, which is b minus a over n, which is 4 minus 1 over n, so it's 3 over n. And then your x sub I is going to be a plus I times delta x. So it would be 1, your a is 1 here. So that's the a value, by the way, and that's the b value. So 1 plus 3 over ni. So we got your delta x and your x sub I, and you're going to use. So there we go. This will be equal to the limit as n goes to infinity of the summation from I equals 1 to n of x gets replaced with x sub I, which is what I highlighted in orange there. 1 plus 3 over ni plus 2 times dx, which is gets replaced with delta x, which is 3 over n, on the interval 1, 4. And you don't need to simplify it. You can leave it as the 1 plus 2 like that. How many of you got that? Let me see how I wrote it out for you on the thing. All right. Give me 1 second. I'll come back to this. Yeah, I wrote it exactly like that. Okay. Does that make sense? Some of you look like you can use a break. You want a break? Very low energy today. What's going on? Number 12. Exam week. Okay. So this one, if you try to plug in x equals 0, you'll get sine of 0, which is 0, minus 0 over 0. So 0 over 0, L'Hopital's rule. So limit as x goes to 0 of, take the derivative of the top. That's cosine of x minus 1 over 3x squared. Now, if you plug in 0, you're going to get 1 minus 1, which is 0, and then over 0. So we'll use L'Hopital's rule again. This time, if I plug in 0, I'm going to get 0 over 0. So again, L'Hopital's rule. It's not always the case you use it this many times, but this is the example that I gave you. All right, this time it's going to be over 6, so we're not going to get 0 over 0. So if I were to plug it in, I'll get negative cosine of 0 over 6. So that's cosine of 0 is 1. So negative 1/6 is the answer. Any questions? All right, we'll keep going, I guess. Number 13. This is a definite integral from -1 to 1 of 4x cubed minus 3x dx. So evaluate the definite integral. So you just evaluate it. Don't worry if it represents the area underneath the curve. If the whole thing is above the x-axis from -1 to 1, then it represents the area. But you just evaluate the integral. So here's what you do. You take the antiderivative. So it's x to the fourth divided by 4. Well, 4 over 4, that's just 1. Minus x squared divided by 2, so 3 over 2. The whole thing from -1 to 1. So the bottom number is your a always. So that's always your a, and that's your b. So it's you read it from a to b. So now what's your capital F of b? You plug in 1, right? So 1 to the fourth minus 3 halves, 1 squared. So that's my capital F of b minus my capital F of a. -1 to the fourth minus 3 halves, 1, -1. Oh my God, this is a even function. I just realized you're gonna get a 0 here. So 1 minus 3 halves minus 1 minus 3 halves. Well, whatever 1 minus 3 halves is, it's minus itself is 0, right? So 1 minus 3 halves is -1/2 minus -1/2 minus and minus is plus, so you get 0. Yeah, that wasn't very fun, but at least you got some practice. Now, number 14 is actually use the fundamental theorem of calculus to evaluate the derivative of an integral from some constant to x of 4t plus t cubed dt. Well, if you remember the second fundamental theorem of calculus, you just take x and you plug it in. Oops, I couldn't even plug it in properly. So it's 4x plus x cubed, and that's it. We'll do another example. That was too easy. Let me know when you're done writing everything down, then we'll do another one.
Professor, for number
Yeah.
14, why do you do x and not t? Because it's 4t.
Yeah, but we plug in x. That's the fundamental theorem of calculus. Part 1 says just take x and you substitute it in.
Oh, okay, thank you. You guys want to do another one now? Let y equal the integral from, say, 2 to x cubed of t squared plus 8t dt. All right, you guys try to do this one. So the question would be, find y prime. Using the fundamental theorem of calculus part 2.
All right, so what we're gonna do is a u substitution. So let u equal x cubed. So du over dx is gonna be 3x squared, right? So we're gonna rewrite this as y equals so y prime is, we're gonna take the derivative with respect to u of this. And then times the derivative of u with respect to x. So this part right here is very similar to the part where I did on the review sheet, except instead of an x, you're plugging in a u. So we're going to get y prime is equal to u squared plus 8u, but then times what du over dx is, which is 3x squared. Now what is u? It's x cubed. So x cubed squared plus 8 times x cubed, the whole thing times 3x squared. So y prime is equal to x to the sixth plus 8x to the third times 3x squared. I guess you can keep going on this, but we'll leave it like this for now. That's fine. If you distributed it, that's fine as well. Either or. I think it was nice, but yeah, I probably should have raised it to a power like some number like 5 or something here, so that way we couldn't go any further. How do you got that? All right, so also want to emphasize when you're studying for the test. So study the different types of problems that I told you. Also, you want to make sure you know that section 4.3 was it? Where we did a bunch of different problems. If I ask you, given f of x, what intervals is increasing or decreasing? You should know it. Or what intervals is it concave up? What intervals is it concave down? Going to the left, you should know it. Those are 4 questions I gave you. I gave you the answers to them. So be familiar with that. Find the relative maximum. Or if I give you a function over a closed interval, you should be able to tell me the absolute maximum. Oh, actually, sorry, the absolute maximum, that was in the last test. But relative maximum. Running a definite integral as a limit of the Riemann sum and vice versa. Fundamental calculus, we just did that. You have 5 questions for me.
First, I have a question.
Yeah.
We need to know about in some of the word problems. There's a distance formula, and can you tell us do we need to know about that, like how to distance formula in the word problems?
Yeah, I mean, you get to use a page of notes, so you should be. You may or may not. Yeah, you should know distance formula.
Oh, that's the thing too. Can you write the distance formula? Because in the book and then like online it's like the numbers are some of the numbers which I don't know if it matters or not.
No, because it doesn't matter because you're squaring it anyway.
Oh, okay. Yeah, some of them says that x squared minus x1 and y squared, or not the second x minus the first x.
Yeah, x sub 2 minus x sub 1 or x sub 1 minus x sub 2. So the order doesn't matter because you're squaring it.
Okay.
So let's say the difference is 5. Well, if you switch the subtraction, you'll get negative 5. But at the end of the day, it doesn't matter because you're squaring it. So it's going to be compounded anyway. Right. Way to remember that by the Pythagorean theorem, but you got to use a page of notes. So, any other questions? Now, I might not ask you a question following this, but I may ask you to maximize a rectangular pen. Maximize only one. I don't know what I'm going to ask you, but it'll be something. All right, anything else? So you guys good? Yeah, so I'm probably about 10 questions. Same format as the other test, about 80 minutes, 70 plus 10 minutes for standing. Try to show up a few minutes early, like if class starts at 3:15, try to show up at 3:10. So there's I tell you, like 3:15 right away. Video's on, your camera's in the right position, you can start taking the test. And yeah, this is the third exam. And then after this, you got a final left. So all I have questions on the final afterwards. I'm not even getting 2 exams this week, so who knows? It's gonna take me a while to grade all these, but we'll see. Well, let's just take it for now, and then that's it. I'm pretty much done with class today. You guys do one more leave. Lauren, what do you think? You want to tell us a story for the class? No, okay.
No, I'm good. Thank you, though.
Yeah, I say thank you though. Very great day. All right. Well, I guess someone else has anything they want to share. I'm not hopefully forgetting anything. Oh yeah, after class, Leah has her tutoring now, so you can see her. I guess I'll see you guys Thursday. We're gonna let you out early. You just decided to leave. Okay. Got that, Desiree? All right. Take care. Bye, everyone.